Am I audible?
Yes, sir.
Okay. So I think we have to. I think last lecture, one numerical was given as a test for all of you. But I think unfortunate thing is there that only one student has replied that PDF or sent that PDF to me. Others have not. What is the problem, Kunal? I told that problem we have to solve as a homework
Sir,
for
I
you.
have sent.
You have sent. Kunal, you have sent. I have not. It
Yes,
on
sir.
my mail.
Yes, sir.
On mail you have sent. Okay.
Yes, sir.
Okay, I will check. Okay. But on WhatsApp. Okay. How many of you have solved? You have sent that? Okay. Kunal, Pramod, Avlikar, Shivanshaneswar. Okay. Then sorry, I have to check. But only 3-4 people. Others they have not submitted. So please submit today after this lecture. Okay. Then last lecture I think we have started the numericals. Am I right? The numericals on vapor power cycle. And those are your friends.
Yes,
Those are not attending these lectures. How they can understand the numericals? So please ask your friends that they should join immediately. Otherwise, very difficult for them to understand these numericals. I don't know why they are not attending. This problem with them, I don't know. But still, request your friends. Those are not attending this lecture. Ask them to attend so that we can have more practice of this numerical, because every examination they are going to be asked the numericals on this. Okay, so I think we have taken that last numerical. Shall I repeat that numerical, or it is solved? Somebody, I think one of student, one minute, I one of student submitted that. Shaneshwar Misal. Rule number 34 is Shaneshwar Misal, na?
Yes, sir.
You have submitted it, na?
34.
Okay, so okay. So this is the, I think, numerical. Shaneshwar has solved it in correct manner, I think. So determine the efficiency of Rankine cycle and heat rejected in condenser using steam as a working fluid, having condenser pressure 10 pascal, 10 kilopascal, and boiler pressure 2 megapascal. Steam leaves boiler as saturated vapor. Okay. So this is numerical. So as usual, I told you that first of all, what we have to do? We have to draw the TS diagram of the numerical. So this is our TS diagram. Okay, temperature versus entropy diagram. So 4 to 1 boiler process, 1 to 2 steam turbine process, 2 to 3 condenser process. and 3 to 4, that is the isentropic compression in pump. Okay, so these are the 4 processes. Okay, then 1 to 2 isentropic expansion, 2 to 3 heat rejection in condenser, and then afterwards boiler pressure is given in megapascal, that we have to convert it into bar because steam table values are in bar. So he has correctly 2 megapascal he convert into bar, that is mega means 6, 2 into 10 raised to 6 divided by 1 bar is equal to 10 raised to 5 pascal, so divided by 10 raised to 5, and the answer is coming as 20 bar. So like this condenser pressure 10 into 10 raised to 3 divided by 10 raised to 5, 10 raised to 4 divided by 10 raised to 5, 1 by 10 means 0.1 bar. Condenser pressure will become 0.1 bar. Am I right? Then, as point number 1 is in the on the vapor line, therefore what table number 2 I have to refer, and H1 is equal to Hg at 20 bar we have to record, and H1 is coming as what 2797.2 kilojoule per kg Kelvin. Am I right? It is not Kelvin. It is wrong. So, sure. It is wrong. Here you have made mistake. It is only it is entropy unit is there. Kilojoule per kg Kelvin. So it is enthalpy, kilojoule per kg only. Take note. Huh? Sure.
Okay, sir. Yes, sir.
So others values are correct. Somebody can give.
Yes, sir. Correct. Yes, sir.
Okay, good. Okay, so H1 is equal to 2797.2 kilojoule per kg. Then we have to determine H2. Okay, and H2 is what? Here H2 is there. Here whatever the arrow is here, H2 is there here. This is the wet region. Therefore, its enthalpy we can calculate with the help of wet steam equation. What is that equation is there? What is the wet steam equation? Here H2 is equal to here HF plus X2 into HFG, and this HF and HFG we have to record at 0.1 bar because condenser pressure is what 0.1 bar. So general make sure make practice that pressure should be written in the diagram so that we can get idea. 0.1 bar at 2 condition, 0.1 bar we have to record. Again table number 2 we have to go for. Okay, then table number 2 means H2 is equal to HF at 0.1 bar 191.8 plus X2 into 2392.9. Okay, and in that case but X2 we are not knowing. Okay, but we have to calculate X2 now, and for that we have to take the help of isentropic condition. The S1 is equal to S2. Here we know that S1 is equal to S2. Yes, TS diagram is there. S1 is equal to S2, and therefore S1 is equal to again SG at here 20 bar. Okay, pressure is of boiler is 20 bar. So S1 is equal to SG at 20 bar. So that we can get. So S1 is equal to SG at 20, not 2 bar, 20 bar. It will be 6.337 kilojoule per kg Kelvin. It is correct. Okay, then afterwards S2 is again the point number is in wave region. Therefore, its entropy will be also similar to enthalpy equation. What is that equation? S2 is equal to SF plus X2 into SFG. In that case, it will become 0.649 plus X2 into 7.502. Okay, and then in that case 6.337 is S1 is there is equal to SF at 0.1 bar is 0.649, and SFG at 0.1 bar is 7.502. And if you do this calculation, then 6.337 is S1, okay, is equal to 0.649 plus X2 into 7.502, and in that case X2 will come as a 5.6588 divided by 7.502 and 0.758 means it is 0.76. Okay, so x2 we got. After x2 we have to put this x2 in equation 1. H2 is equal to 191.8 plus x2 into 2392.9. Okay, in that case we put x2 is equal to 0.76, then we get that case we can get the equation value H2 is equal to 2005.61. So if you do this, X and H2 will be kilojoule per kg Kelvin. Okay, then H3 is equal to HF at 0.1 bar. HF at 0.1 bar. Therefore, H3 is equal to 191.8 kilojoule per kg Kelvin. Okay, because this is equation a 191 only. This is the value of H3 in this equation. You have to know that. And H4 is equal to H4 plus H4 is equal to H3 plus W pump. Okay, and now H3 we know, W pump we can calculate with the help of pressures, bar, boiler pressure and condenser pressure. What is that equation? W pump is equal to zero point 0.1 into boiler pressure in bar minus condenser pressure in bar, and it will become 1.99 kilojoule per kg only. So okay, then here H4 is equal to 193.79. Unit is kilojoule per kg. So this equation is there. Everybody are getting same answers. H1, H2.
Yes, sir.
Okay, good. Kunal,
Yes, sir.
okay. Okay. Pramod is also getting same. Okay. Then efficiency of cycle. We are having the formula. What is that formula? Heat supplied minus heat rejected divided by heat supplied. So H1 minus H4 minus H2 minus H3 divided by H1 minus H4. This formula we have to keep in mind. Okay, very simple. If you know the diagram and if you know the processes correctly, only simple thing is there, that heat supplied minus heat rejected divided by heat supplied, or the work done by turbine minus work done by pump divided by heat supplied. And here from equation A, B, C, D means A, H1, H2, H3, H4, if you put, efficiency is coming as 30.32. And I have told you that efficiency is in the range of 30 to 40%. So this range is coming correct. I think it might be correct. Okay. Then W net is equal to work ratio is, they asked, W net divided by W steam turbine, and is equal to WST minus W pump divided by WST. Okay, and therefore WST is equal to H1 minus H2. Okay, and then is equal to 791.59. W pump is equal to, or already we have 1.99. Then the work ratio is equal to 719, WST 719.59 minus 1.99 divided by heat supplied. Sorry, W steam turbine is 791.59 and is equal to 0.997. Already I told you that work ratio is always in the range of near to 1, maybe 0.98, 0.99. Here is very, very near to 1. So heat rejected in condenser is equal to H2 minus H3. Okay, and is equal to, heat rejected is equal to what? Here 2005.61 minus 191.8, and therefore it is equal to 1813.81 kilojoule per kg. And SSC is coming as 3600 divided by W net. W net is equal to W turbine minus W pump, and is equal to 4.55 kilojoule per kilowatt hour. And then in that case, heat supplied in boiler H1 minus H4, if you do it, 2603.41. Very good, Senator, but only unit care of units you have to take. Okay.
Okay, sir.
Okay, those are your friends. Ask them to join by giving anything. Senator, to take care of units only. Yeah. Other things I think
Yes,
correct.
sir.
Shall we proceed to next
Yes,
numerical?
sir. Yes, sir.
Okay. So good. Those are submitted. It is very good. Those are not submitted. Please submit it fast. Okay. Okay. So this is I will go to the next numerical. On that day, that numerical we had taken from PowerPoint presentation, na?
Yes, sir.
Okay. So okay. So here, if you see that we are in other numerical is there. This numerical were taken. Am I right now? 2.5 or this only were
Yes, sir.
taken. 2.5 megapascal. Let us have practice this. 2.5 megapascal were solved. Not solved, na? 25 bar and zero point 0.1 bar. I do not solved. So let us this have one practice numerical. Solved. This
Solve, sir.
already solved.
झाले.
झाले?
सॉल्व केलंय सर.
Solve.
Okay, good. Okay, now this numerical will take. Chalo. Okay, take this numerical. Hello. हाँ सर. 1 minute I'll take. हाँ. Are you busy? I am taking lecture, but I just. I'm sorry. This leave application. So how it is to be? Your sign is there or? No, it is. Why? What is that? Tomorrow's leave application. Leave application. Your HOD can sign one day. Huh? One day the HOD can sign. They have signed. But now Dean signed. So shall I take your now sign? Because Power sir no Dean Academy. I went to Power sir. Power sir said कि बाबा you talk to Zankar sir because this process you know. Then I went to Hello, is numerical is visible to all?
Yes, sir.
Have you started
Yes, sir.
solve? Okay, good. Somebody can solve and put the PDF so that it will be better for me to refer. Actually, it is there with me, but still. So it is proposed to at least Carnot cycle. Okay. So before that, okay. So we'll numerical is solved by everybody. Numerical solved by everybody. Sorry, written by everybody. Put yes, 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 so that I can go to next slide. So again, the numerical is there that dry and saturated steam is supplied to a turbine. Okay, but now they are asking that here. Hello. No problem. So okay. So it is proposed to operate a vapor power cycle using steam as a 2 megapascal. Now 2 megapascal means 20 bar, that we know. So 2 into 10 raised to 6 divided by 10 raised to 5 is equal to 20 bar. Okay. At the same time, here P condenser is equal to 7 kilopascal is equal to 7 into 10 raised to 3 divided by 10 raised to 5 is equal to 0.07 bar. Okay. And then Carnot cycle efficiency we have to calculate. Okay. Now Carnot cycle and Rankine cycle, both cycles efficiency we have to compare here. Okay. Carnot cycle is an ideal cycle. So here therefore the heat addition process, if you assume the cycle as a Carnot cycle, it will only cover into this saturated curve, because heat addition during only this dome or curve will remain isothermal. So 4 to 1 is isothermal heat addition in Carnot cycle, and 2 to 3 is isothermal heat rejection in condenser in Carnot cycle only. Okay. Therefore, this Carnot cycle is bounded by a curve in say square. Okay, this kind of 4 to 1, 1 to 3, 2 to 3, 3 to 4. Because due to isothermal limitation, this process will not come outside this curve. Therefore, this is the Carnot cycle. Okay, and we know that Carnot cycle efficiency depends on only anybody who is there. Okay, who is studying at here I can get. Carnot cycle efficiency is function of only anybody?
Temperature.
Temperature only, correct. So therefore, Carnot to temperature. So therefore, eta Carnot is equal to 1 minus T2 upon T1, or T1 minus T2 divided by T1. We have solved this, we have got this derivation, or we have got this formula. Am I right? But T1 and T2 should be in Kelvin. Now, what will be T1? T1 काय असू शकते, कोण सांगा बरं. T1 is equal to T4 काय असते, काय असू शकतो T1 is equal to T4? एनीबडी? कसा फाइंड आउट करावं लागेल आपल्याला? थोडस काय म्हणतात त्याला, डोकं थोडं ही करा, अप्लाय युअर माय ब्रेन लॉजिक and tell me. काय असू शकतो T1 इज इक्वल T4 कसा फाइंड आउट करावं लागेल थोडंसं लॉजिक थोडंसं ब्रेन एनीबडी कोण सांगू शकते नोबडी ओके सो T1 इज इक्वल T4 काय असतो T1 हा इथलं टेम्परेचर काय असतं आतलं कुठलं टेम्परेचर असतं सॅच्युरेशन इथं सुपर हिटेड टेम्परेचर असू शकतं इथं सबकुल्ड आणि इथं मधलं कुठलं आहे सॅच्युरेशन देअर फोर इथं प्रेशर माहित आहे इथलं सॅच्युरेशन टेम्परेचर किती असणार काढू शकतो आपण T1 इज इक्वल टू टी सॅच्युरेशन ऍट 20 बार आपला टेबल नंबर 2 यूज करायचा आणि सॅच्युरेशन टेम्परेचर किती आहे 20 बारला दॅट वी हॅव टू फाइंड आउट ओके अँड इज इक्वल टू व्हॉट 212.4 डिग्री सेल्सिअस आणि हा केल्विन मध्ये करायचा असेल तर 212.4 प्लस 273 हा किती होईल तुमचा 485.4 केल्विन एव्हरीबडी अंडरस्टँड तसंच T2 पॉइंट नॉट प्रेशर किती आहे 0.07 बार तर ते सॅच्युरेशन टेम्परेचर किती असेल 0.07 बार प्रेशरला किती टेम्परेचर असेल बघायचं व्हॉट इज दॅट टेम्परेचर इज इक्वल टू 39.03 डिग्री सेल्सिअस जर टेम्परेचर केल्विन मध्ये केलं तर किती येणार 312.03 केल्विन मग किती झाले ते दोन्ही मिळून किती झाले हियर इफ यू कॅल्क्युलेट इटा कार्नॉट इज इक्वल टू 1 मायनस 312.03 डिवाइड बाय 485.4 and the efficiency is become as 35.71 this is a Carnot cycle efficiency हे न्यूमेरिकल 2-3दा परीक्षेला आलेलं आहे ओके Carnot cycle efficiency कशी फाइंड आउट करायची बिकॉज इट इज अ फंक्शन ऑफ ओनली टेम्परेचर त्याला टीएस डायग्राम आपल्याला माहित आहे तशी काढली आपण ओके फर्स्ट ऑफ ऑल ड्रॉ द टीएस डायग्राम ओके देन आफ्टरवर्ड्स we have obtained the temperatures saturation temperature from the corresponding pressure that is T1 is equal to T sat at 20 bar 212.4 त्याला आपण केल्विन मध्ये केलं 485.4 तसंच T2 is equal to T saturation at 0.07 bar तो 39.03 डिग्री सेल्सिअस आला आणि T2 आला आपला 312.03 केल्विन इटा कार्नॉट आपला किती आला 1 मायनस 312 आणि त्याप्रमाणे 0.35.71% एव्हरीबडी अंडरस्टँड काय अडचण प्लीज राईट मेसेज इन मेसेज बॉक्स फास्ट राईट फास्ट so that I can go to next Kunal no problem Nikita Pawar no problem okay Shineshwar Misal no problem Prashant Mali no problem so shall I okay everybody got how to calculate Carnot cycle efficiency okay then efficiency of Rankine cycle now we have to draw the TS diagram for Rankine cycle when steam entering to the turbine is dry and saturated like our usual method what is that the efficiency of Rankine cycle okay so 4 to 1 1 to 2 is steam turbine process 2 to 3 is heat condensation 3 to 4 here heat isentropic compression in pump okay and then 4 to 1 heat addition in boiler okay and then in that case now our usual practice whatever numerical we have solved this procedure I think it was little bit different than other numerical I have therefore told you specifically now here you can proceed with this can you proceed put your remarks and go further so that I can get that I will give some time to you to solve okay so Kunal Nikita Pawar Kunal Shubham no problem for them okay okay so continue Prashant Mali also no problem okay Swaz is there? Swaz, you are not responding. Swaz,
Yes, sir.
uh, are you solving?
Yes, sir.
I have not find your response. Therefore, I getting, huh?
Yes, sir.
Solve. I will give some time to you. 5 to 10 minutes. 5 minutes, no problem. 5 to 10 minutes, and we'll compare your answers. Actually, H1, S1 will be same because last previous numerical you have solved that. H1 is equal to Hg at 20 bar 2797.2. H2 is Hf plus XHFg at 0.07 bar. Then 163.4 plus X2 into 2409.n. Calculation of X. Same procedure. All numericals were to apply. S1 is equal to Sj at 20 bar 6.337. S2 is equal to Sf plus X2 SFG, and X2 is coming as 0.75. Like we solve. I'll give 5 minutes to you. Okay. So Kunal Kunal is getting current efficiency as 37.15%. Okay, good. It is correction is there. Okay, Kunal. Okay, no problem. And Nikita Power is getting Rankine cycle efficiency as 31.53%. And Kunal is getting 32.25%. Okay, we'll see majority. Others will wait. Somebody is others answers will wait and we'll check the answers. So here I think okay for others reference 31.34. Both may be correct. That is not the big issue. Others are don't leave the class. Be in the class and solve. Only for attendance purpose, don't sit. Okay, promote only core. Ranking 32.25%. Little bit here and there because how much digits you are considering for that x2 variation will be there. So if you consider it, I told you to consider 2 digits, your answers will be that answer we have to consider because book are considered in the book. This only 0.748 they are considering as 0.75. If you considering 0.748 completely, then answers may be little bit different. Some variation. It may be accurate, but as per the book, you are away from the book answer. Okay, Pramod Aulikar. Okay, Kunal is getting work ratio, but Kunal your answer other okay. Work ratio 0.997. Good. Other parameters you can calculate, no problem. Okay, now with this, now we'll H1 is equal to Hg at 20 bar 2797 we got. H2 is equal to HF plus XHFG at 0.07 bar. Okay. Then HF 0.07 bar, that HF and HFG we have to record from steam table. Okay, steam table HF is equal to 163.4, HFG is equal to 2409.2. So this value I think everybody know how to take the value. Table number 2 I have to go for. Then this equation we have to write 163.4 plus x2 into 2409.2, equation number 1. Then calculation of x2 we have to write, okay, and then but s1 how we are calculating S1 is equal to S2 with that consideration. S1 is equal to S2 isentropic expansion in steam turbine. But S1 is equal to again SG at 20 bar. Therefore, S1 is equal to SG at 20 bar. Okay, and is equal to 6.337. Okay, and the same time S2 is in wet region, point number 2, and at 0.07 bar pressure. So S2 is equal to SF plus X2 SFG is equal to 0.559 plus X2 into 7.718, and as this is equal to same S1 is equal to S2, we can write 6.337 is equal to 0.557559 plus X2 into 7.718, and therefore if you consider X2 is 0.75. Am I right? Everybody's X2 is coming as 0.75, right? Yes, yes, yes. So that we first, then if you put H2 is equal to 163.4 plus 0.75 into 2409.2, then H2 is coming as 1970.3 kilojoule per kg. Okay, and then H3 is equal to HF is equal to H3 to HF at 0.07 bar and is equal to 163.4 kilojoule per kg. Okay. Then H3 is equal to HF. Okay. Then H4 is equal to H3 is equal to 163.4. Okay. Then H4 is equal to H3 plus W pump. W pump we have to calculate as a uh, 0.1 into boiler pressure in bar minus condenser pressure in bar, and the value is coming as what? 1.957 951. Am I right? 1.951. Okay, and H4 is coming as what? 165.39. 165.39. If you put the values, eta Rankine is equal to H1 minus H4 minus H2 minus H3 divided by H1 minus H4. And in that case, if you put all the values, the efficiency is coming as 31.34%. Okay. So remember that always, that efficiency of Carnot cycle is always more than the other cycles, because Carnot is an ideal cycle. It has not considered any kind of friction in it. The processes are reversible processes. These are the ideal processes. Cycle is ideal, no losses, and hence efficiency of Carnot cycle is more than the efficiency of Rankine cycle always. Okay, so eta Rankine is equal to 31.34 percentage. So those some students are living in between. I don't know why they are doing this thinking. Don't leave. Tell to your friends those are attending. Don't leave the class in between, so that everything is important. So these numericals are asking for examination for 5 to 6 marks. So for the examination point of view, we should not attend the lecture, or here everything is important, each and every sentence. Okay, and your work ratio, if you want to calculate, then W net divided by W turbine, and that everything we can know, and WR is equal to 0.99. Some of Kunal has also solved, and he has got the work ratio as a 0.997, 997, 999. Okay, then WST. Okay. Now here another numerical for practice. Same numerical. I want five within 5 minutes. We have to complete this task today only. Hello. Okay. Is this numerically visible to you? This numerically visible to you? Yes, Suhas is yes. Yes, sir. Okay. Now you can solve this. In a Carnot cycle, steam supplied to an engine is dry saturated at 15 bar. Full stop. The steam expands isentropically to a pressure of 0.2 bar. If the liquid supplied to the boiler is saturated, okay, at 15 bar, the steam expands isentropically to a pressure of 0.2 bar. The liquid supplied to the boiler is saturated at the entry to the boiler. Calculate cycle efficiency. If Rankine cycle is operated between same pressure limits and steam is dry saturated at the entry to turbine, calculate cycle efficiency. Compare both cycle efficiencies and comment. Means we have to calculate both cycle efficiencies and we have to comment which is better and which is less. That way one sentence. Okay, so those are not again not having confidence for them. I will solve fast. Is it visible? Point the new screen. Somebody can reply. Okay. So is mark is pen pointer is available? Whatever. I have drawn one line. Whether it is visible. Because I want to solve numerical. Somebody. No. Okay. Is it visible now? Whatever I'm carrying out operation on screen, whether it is visible?
Sir, only screen is visible.
Okay. Okay. Then I think here we have to. Okay. Now it may be visible.
Yes, sir.
Okay. Permanent. Okay. Don't leave in between. Okay. So first of all, Carnot cycle efficiency will find out. TS diagram I have to draw. Consider this as a vertical line. This is a TS diagram. Okay. This is our cycle. This is boiler pressure. Okay. This is boiler condition. Condenser. This is steam turbine. This is pump. This is 1, 2, 3, and 4. What is boiler pressure is there? 15 bar. This pressure is and this pressure condenser pressure is how much? 0.1 bar. Okay. Correct, na? Am I right? Okay. Then T1 efficiency of Carnot cycle is function of only two temperature. That is T1. This we can call
Sir,
it as a
0.2 bar.
point
2 bar.
0.2 bar. Okay.
0.2.
0.2 bar. Zero point 0.2 bar. Okay. So we know that efficiency of Carnot cycle is function of temperature only. And is equal to 1 minus T2 upon T1. Okay. Then T2 is equal to what is T2 and what is T1? We have to find out. What is T1? It should be in Kelvin. T1 is equal to T sat, T saturation temperature, T sat at which pressure? 15 bar. and is equal to, who will tell now? T sat at 15 bar. Kunal, fast you tell. T sat at 15 bar. Saturation temperature 15 bar. Have you solved, Kunal? Kunal or somebody who is ready with answer, please tell. T1 is equal to T set at, otherwise I have to go for my stream table also. Anybody not ready? You can put your answer.
198.3.
Okay. 198.198.3
3.
degree Celsius.
Yes, sir.
And Kelvin, convert it into Kelvin tell. Somebody can tell.
471.3.
471.3.
3.
Take here in Kelvin. Similarly, T2 is equal to, what is T2? T2 is equal to T saturation again. At what pressure? Point 2 bar. Okay, and is equal to, who will tell now? Kunal Loy only. Fast Kunal, so as far those are having answer, ready answer. T sat is equal to 0.2 bar. What is that temperature?
17.5 degrees Celsius.
Say 17
Yes, sir.
point 5 degrees Celsius, and is equal to maybe 300.5 Kelvin. Am I right? Correct? Null. Okay.
Sir, 290.5.
Sorry, 290. Sorry, 290.5. Okay, good. 90.5 Kelvin. Okay. Now, okay. Now here eta Carnot you can put here. Therefore, eta Carnot. One minus T2 is 290 divided by T1 is 471.3. How much it is coming now? Somebody.
Sir,
0.38.
pressure is 0.2 bar.
0.2 bar only. Correct. We have taken 0.2
Sir,
bar.
you have taken that T set for 0.02.
No, 0.2 only. Here I have written 0. Here it is point.
No, sir, but that T set value, sir, wrong.
T set
Yes, sir.
value is wrong. It is, I think he
That is
only. Kunal only.
60.9.
60.9.
Ha.
Alright, Kunal. Okay,
Yes,
then
sir.
we'll
Yes,
check it.
sir.
He is correct, na? Okay.
Yes, sir.
Good. Okay, very good. Kunal, you correct, na? Here it how much?
60.9. 60.9.
60.9. Tell me in Kelvin now.
333.09. 0.9. 0.09.
3, 3.09.
0.09.
Am I right? Now it is correct.
Yes, sir.
And here also. Here 3.09. Good. If somebody is making mistake, you have to, others have to correct it. Good. So this is our called as group work. Okay. Then it is coming as how much? 333. Somebody can
0.29.
0.29. 0.29. This much less. Okay.
Yes, sir.
Okay. Or in bracket also we have to mention in percentage. 29%. If point is there, you can also write the point. I think everybody understood, I think. This, no problem. 29.32%. Shubham Singhan. Good. Good, Shubham. Okay. Then we have to go for its ranking cycle. Okay. Then how to go for ranking cycle? Draw again TI diagram. Only I will write the only H1, H2, H3, H4. Again, steam supplied is dry and saturated. That okay. So 1 to 2 steam to turbine, 2 to 3 condenser, 3 to 4 pump, and boiler pressure is 15 bar. Here is condenser pressure is 0.2 bar. Okay. Then H1 is equal to Hg at 15 bar. Who will tell? At 15 bar.
2789.9.
27 8
9.9.
0.9. I will not write in units. You consider that kilojoule per kg is there, because I think it will waste time to write the text with this mouse. Okay, then H2 is equal to HF plus X2 HFG, and H2 is equal to this we have to record at 0.2 bar. Therefore, HF at 0.2 bar, HFG at 0.2 bar, and equation you tell. You will tell fast somebody. HF at 0.2 bar, HFG at 0.2 bar. Somebody can help me. HF. Nikita, Power, are you solving?
Yes, sir. HF 251.5.
251.5 plus X2 into help HFG
2358.4.
2358.4. Okay. Then we have to determine X2. And for that, what we are doing? S1 is equal to S2. I will not write no explanation. S1 is equal to S2 because isentropic expansion. And similarly, S1 is equal to SG because point is in dry saturated curve on dry saturated vapor line. SG at 15 bar. And who will tell now? Somebody who is online. Nikita, Kunal, Gaurav. Somebody can Suhas. Fast. Okay, Suhas must be 0.71. What is 0.71, Suhas? Somebody can tell S1 is equal to SG at 15 bar. Who is online or who is updated? Kunal.
Sir,
Don't
S1
waste
is
the
equal
time.
to 6.441.
S1 is equal to
6.441.
6. Don't wait. I shouldn't take name. Those are radiate answer they can tell. Kilojoule per kg Kelvin. And S2 is equal to, now tell me equation.
SF
SF
plus X into SFG.
x2 into SFG and is equal to, somebody can tell. 0.7 x2, good. 6 point, good to us.
0.79. X2 is
Point
equal to 0.1.
directly, but values okay. Shall I others look at it? Those are not knowing stream table. They can note down the L values. SF at 0.2 bar you tell.
0.832.
0.832 plus x2 into SFG
7.077.
7.07. Okay, 7.077.
7.
So it is equal to 6.441, and there we'll get the value of x2. What is that value of x2 is coming? 0.80. To us is coming 0.71. Shubham is coming Shubham Gandole is having answer 0.80. What's about you, Kunal?
0.79.
0.79 means near to 80. 0.79 digits, you can tell third digits. 0.79 something, more than 5 digits.
792.
792, okay. 0.79, okay. Nikita, your answer. Gaurav, next answer. Okay, 0.79. Okay, majority will consider answer as a 0.79. Okay. Then x2 we got, then h2 is equal to, put that value in h2 equation. Give the equation number 1. Not directly tell me value. X2 only you have to put. I will not write all these things because problem it will take time. Somebody can tell H2 value.
2114.
One can somebody. So Shubham, okay. Shubham is speaking for Shubham.
2138.22.
2138.22. Correct. अनुमोदन तर द्या कोणी यांचा आन्सर बरोबर आहे म्हणून. ओके 2138.22. ओके नो 2114.63. कसा फरक पडतोय हो एवढा? शुभम
तर त्यानं 0.80 घेतली त्यामुळे व्हॅल्यू चेंज झाली.
0.80 घेतले काय कुणी? आपल्या आहे ना. ओके गौरवनं. ठीक आहे असं थोडंफार काय झालं ते म्हणजे डिजिट्स करताना मी तुम्हाला सांगितलं 2 डिजिट्स पर्यंत कन्सिडर करा. 0.79 घ्यायला पाहिजे. ठीक आहे. देन H3 is equal to, no problem, H3 is always equal to what in this case or every here 251.5 kilojoule per kg. Okay, then W pump we have to calculate. Is equal to 0.1 into P boiler in bar minus P condenser in therefore W pump is equal to minus 0.2 and how much it is coming? Anybody help me?
1.48.
1.48. my internet connection. Okay, so still that am I audible now?
Yes, sir.
Okay, so H1 is equal H4 is equal to 257. Am I right? Then anybody? Hello, I am audible.
Yes, sir.
Okay. Now tell me value of H4. Some Kunal, you
Yes, sir.
present your numerical. Till that
Okay.
I will get internet connection on my PC. Okay. Present your numerical.
Yes, sir.
Have
Last
you
part.
got PDF? Have you made PDF? Completed numerical?
Yes, sir. Complete.
You hello. You
Yes.
you make put PDF on
Okay, sir.
screen. I will continue.
Okay, sir.
Okay, so Nikita Power got 26.55. So Nikita, your Carnot cycle efficiency is more na than this ranking cycle.
Yes, sir.
Okay, so Carnot cycle efficiency is always more. That we have to take care while solving the numerical. Carnot
Yes,
cycle
yes.
efficiency came, I think, 29%. So our
22.
efficiency become 26%. Good. Then, Kunal, are you making PDF?
Yes, sir. Yes, sir.
Okay, okay. Gaurav, I have solved. Gaurav is left, I think. Somebody does. Kunal, why time is required or your
Yes, sir. Present?
presented?
Not sir. 1 minute.
Okay.
Visible, sir?
Okay, visible to all. Others, for me, no problem. Faint, clarity is not there, Kunal. You are using black pen here, I think we are getting. Okay, now it is clear. Okay, others, you are getting others. Yes, okay. Then you go to directly value calculation of H4 only. Kunal. Okay, X2 is 0.70. Okay, now clear it. Okay. Now, okay, H4 is equal to 251.5 plus zero point 0.1 into 15 minus zero point 0.2, and it is coming as 252.98. Correct, H4. Then efficiency will become now eta ranking is equal to heat rejected, okay, half page only, Kunal. H1 minus H4, okay, minus H2 minus H3 divided by H1 minus H4, and it will become now, if you put all values of H1, H4, then H2, H3, okay, and then it will become, now efficiency will become 26.55%. Okay, then what should be our comment? What should be our comment? What should be our comment? Comment is that Carnot cycle efficiency is greater than Rankine cycle efficiency. Carnot cycle efficiency is greater than Rankine cycle. Okay, I got now my internet connection. Good, thank you. Thank you those who have assisted me in this numerical. Nikita, Kunal, okay, Gaurav. Then, okay, now next numerical will go for here superheated steam supplied to the steam turbine. It's okay. Is screen visible?
Yes, sir.
Okay. Now numerical is visible clearly. Kunal.
Yes, sir.
Okay. Now take this numerical. This will be our today's last numerical, and I think maybe if you will decide, then next chapter, next lecture will start new numerical, new chapter, second section. But till this, I think this is the last numerical. If, other practice numerical you have to practice at your home. Same kind of numericals they are asking. Rankine cycle has steam entering in the turbine at 140 bar and 550 degrees Celsius. If the exhaust pressure is 0.65 bar and all processes are reversible, find A cycle efficiency, B work ratio, and steam rate. Steam rate means specific steam consumption. Part B you don't forget, don't consider. Only part A. Only that, up to that you can write. Okay, if your numerical is over, then tell me. Yes, you write your message that yes, as usual, numerical is over, so that you can solve more. Okay, so Nikita Pawar, Kunal. Okay, okay, they are completed. Okay, now this is now superheated steam. Now what is quality of here? Steam type supplied to the turbine. What is the steam type supplied to the turbine? Anybody?
Superheated.
It is superheated, not here dry and saturated. So superheated steam is supplied to the turbine. Okay. Therefore, point number 1 will come on superheated region. So here we have shown. So our nature is like this. So this is our superheated zone, and from that isentropic expansion happen. Okay. So this 2 should be like this. Okay. So 1 to 2 visible. Okay. The steam is what? 1 to 2. Steam is superheated. Pressure is 140 bar and 550 degrees Celsius. And here, this cycle, this here, like this you consider. 2 points should be inside this particular weight region. So that student has made mistake. Okay. So point number 2 should be in weight region. Okay. And then same way, same procedure we have to do. The only thing is there that here point number 1, which table to find out enthalpy of point number 1, what do I have to do? Which table we have to refer? Anybody? Which table we have to refer?
4. Table number 4.
Table number 4 to find out the enthalpy superheated steam. Others are same. Point number 2 will be in super weight region. HF plus X2 into HFG, that will not change. Only S1 and H1 we have to take the help of superheated steam tables. Okay. So similarly, I think we have to draw the diagram. So that student has drawn the diagram. So 1 to 2, 550. Okay, 2 to 3, 3 to 4, and 4 to 1. So then H1 is equal to what? H soup at 140 bar and 550 degrees Celsius. So table number 4. But I think 550 is not available in steam table. Correct, na?
Yes, sir.
Am I right? Now it is in 500 and 600. It may be there. Correct? 140 bar is available. But 500 degrees Celsius and 600 degrees Celsius. But we know that 550 degrees Celsius is mean of 500 and 600 degrees Celsius. So therefore, H1 is coming as by table number 4 because superheated steam Am I right?
Yes, sir.
Okay.
Yes.
Then H1 is coming as 3456.15. Similarly, point number 2 is in the which region? Weight region only. And what is pressure? 0.65 bar. So pressure is 0.65 bar. Okay. Then again, here H2 is equal to HF plus X2 into HFG at 0.65 bar. Then again HF and HFG at 0.65 bar. We have to draw the equation. S1 is again S soup at 140 bar and 550 degrees Celsius. So is equal to 6.555. S2 will be same at 0.65 bar. त्यानुसार काढून X2 पॉईंट आउट करायचा आहे. एवढे वी अंडरस्टँड. फक्त काय करायचं पॉईंट नंबर 1च्या प्रॉपर्टी घेताना फक्त सुपरहिटेड स्टीम टेबल वापरायचा आहे. अदर प्रोसिजर इज रिमेनिंग सेम. पॉईंट नंबर 1 लाच फक्त कुठल्या पहिलं सुपरहिटेड स्टीम टेबल वापरायचा आहे. अदर थिंग विल रिमेन सेम. म्हणजे H1 इज इक्वल टू टेबल नंबर 4 आणि S1 इज इक्वल टू टेबल नंबर 5 वापरायचा आहे. एनीबडी हॅव प्रॉब्लेम? Can you continue? Tell your write in message box here. Yes, Nikita Power, no problem. Shubham, no problem. Suhas, no problem. Okay, Kunal, I think no problem. Till I will try on PPT. Okay, those have completed numerical. They can send me the answer. Gaurav Karande also no problem. Is it available? Sorry, is it visible? Blank screen. And
Yes, sir.
that pointer I am making some changes here. I am writing something on screen. Whether it is visible? Not, I think.
No, sir.
Okay. Then we have to go for an entire screen presentation. Till that you can solve. I will Okay, now it is visible, I think. Screen is visible. Whatever I am doing changes. Balaji Pise, are you solving?
Yes, sir, solving.
Oh, any problem facing problem? Balaji?
No, sir.
Okay. So this is our TS diagram. Understand that this is a vertical line. I'm trying my best to make, but okay. So this is our boiler pressure line. The steam is superheated. And from this, okay, this is point number 1. Process happens in steam turbine. That student made mistake in this showing the point number 2. Here it is point number 2 is in wet region. And then afterward, this is the entire process. This is the 4 tone is the entire process. Okay, and what is pressure? 140 bar. Condition is 140 bar. And 550 degrees Celsius. Okay, and here pressure is 0.65 bar. So little bit tick to solve. Okay, then H1 is equal to H soup at, this is our diagram, 140 bar. And 550. And how much it is coming? Anybody? You solve
3, 4, 5, 6.
1 meter. Okay, need slowly. 3,
4,
3, 4,
5, 6,
5, 6. Okay,
0.15.
0.15 kilojoule per kg. I will write. Okay. Okay, then H2 is equal to wet region. H2 is equal to HF plus X2 HFG. And now tell me. Final answer you tell. HF and HFG. Somebody can tell.
HF is equal to 368.6.
368.6 plus X2 into HFG.
2288.
2, 2,
88.35. 35.
8.35. Okay. Then S1 is equal to again
6.555.
okay, yes, soup. Okay, and is equal to what? 3, how much?
6.55.
6 0.55. Okay. Then this S2 is equal to SF plus X2 SFG and is equal to first untanga. S1 is equal to S2. S2 is equal to SF plus X2 SFG.
SF is equal to 1.1695.
1.1695.
95.
After doing that iterations, etc. Correct, na? I had told very methods how to extract data from formula plus x2 into x2 into SFG
6.336.
okay. If we equate this equation with this, because s1 is equal to s2, what we are getting, s2 is equal to, some of you, Kunal only got answer 0.85. You have to take, all are agree. Shubham is also getting same. Okay. Nikita, for efficiency she got okay. 36.64. Good, very good, Nikita. Efficiency 36.69. Good, Chaneshwar. Okay. Then H2. H2. Will now tell the value H2. Kunal.
2313.
2313.
0.6975.
0.6975.
75.
Okay, at 6975. I will consider 69 out. I am getting. Okay. Kilojoule per kg. I assume now. H3 is equal to, now already we got value. Okay. Previously how much we got? H3 is equal to 368.6. Kilojoule per kg, I assume. W pump. Shall I write now only 0.1 into 140 minus 0.65. How much it is?
13.935.
13.9.
935.
Okay. Kilojoule per kg. And H4 is coming equal to H3 plus W pump is equal to how much? So also got 36.71. Everybody is getting 36.17 near about answers. Very good, very good. H4
382.
382.
0.535.
53. I will write only. Okay. And H1, H2, H3, H4 you got. Then eta ranking is equal to H1 minus H4 minus H2 minus H3 divided by H1 minus H4. Put the values and we will get efficiency as 36 point. Right, 7. Near about 7 is. Okay, 36.7%. Then work ratio, Nikita got 0.98. Okay. Shubham Singhan also 0.978. Good. No problem. So other shift calculation you can do it at your own. You can do it, na? Kunal, no?
Yes, sir.
Okay. Others that work ratio, what they asked, that you can do it. So this kind of numerical they are asking. When superated, only when superated steam is given, then instead of that point one, H1 and S1 only we have to take from superated steam table. Other procedure is remaining same. And very less case they will give the wet steam, because wet steam is generally not supplied for the power generation purpose. So wet steam is supplied only for that small application like is heating, mixing, that kind of cases. But here they are not going to give or supply wet steam for this power generation purpose. Okay, so I will take attendance till that you also solve. I will check the answer at the last. Shubham Shingan, SSC 3.19. Okay, we'll see that. Other Sineshwar Mishra, SSC 3.198. No problem. Okay, still that I will take attendance. It is 9. Roll number 1 to 10. Kunal 3.198, no problem. Nikita for SSC also no problem. Okay, good. Everybody is solving and they are having close answers. So no problem. So one more numerical you take from assignment booklet. Okay. So after attendance I will give. First attendance. Roll number 1 absent. 2 absent. 3 4 5 6 7 8 9 10 11 present. 11 Swaz.
Yes, sir.
Okay, Swaz is present. Okay. 12 13 14 15 16 17
17 present.
okay 17 18 18 19 20 21 22
Yes, sir.
23 okay 23 24 25 26 27 28 29 30 31 31 32 33 34
Yes, sir. 34.
34 present 35 34 present
Yes, sir.
35
31.
35 also
Yes, sir.
present. Okay, 36 37
Present, sir.
okay 37 present 38 39 40 left no only
40 present,
41
sir.
okay present okay 41 42 43 44 45 46, 46, 47,
47. Yes, sir.
47 present,
47.
48. Okay, 47 I have taken. 14, 8, 49, 50, 51, 52, 53, 53.
Yes, sir. Yes, sir.
Okay, okay, 53 present. 54, 55, 56, 57, 58, 59,
Yes, sir. 58 present.
58, 59, 60, 60, 61,
Yes, sir. Present 61.
61 present. 62, 63, 64,
65 present, sir.
okay, 65 present. 66, 66,
काय पण पडलं का लेक्चर
56, 67,
येस सर
okay, 68, 69,
Present, sir. 69.
69. ॲबसेंट असं आहे प्रशांत कधी कधी हा समजते का?
हाँ सर समझ.
ओके 70, 71, 72, 73, 74, 75, 76, 77 and 78
78
present.
present.
ओके. निकिता मी ॲबसेंट होता लास्ट लेक्चरला.
सर नेटचा
निकिता,
प्रॉब्लेम. हा सर.
ऑल गर्ल्स आर वेरी प्रेझेंट ॲबसेंट. बाकीच्या मुली
Number 2
ॲबसेंट असतील.
present.
रोल नंबर 2
Roll number
प्रेझेंट.
2.
ओके ओके गुड. हां
Hello,
प्रेझेंट
sir. Roll number 59.
59
चालेल.
प्रेझेंट पकडलंय. हां एनी ऑर्डर answers now. Okay, Kunal, no problem. For the work ratio 0.98, SSC 3.198. Only this much is asked, na? Work ratio, efficiency, and SSC. Okay. Now I think I'll give the next numerical to you.
सर
Okay, anything,
लास्ट पॉईंट राहिला त्यातला क्वेश्चन मधला.
कुठलं? Steam rate का?
सर if efficiency of turbine is 80% and of pump is 50%, what is the actual efficiency of cycle?
आता तुम्हाला दुसरं लेक्चर आहे का घेऊया? कंटिन्यू करूया. बघा 10 मिनिटं.
ओके सर.
काय पुढच्या वेळेस घ्यायचं का आत्ता घ्यायचं? आता लेक्चर आहे का नाही पुढचं?
आहे सर.
मग किती वाजता आहे लेक्चर पुढचं?
3:30.
बरं वाटतं मग रेस्ट घ्या थोडीशी 15 मिनिटं. हां
ओके सर.
ठीक. पुढच्या वेळेस मला आठवण करा राहिले म्हणून. हां
ओके सर.